And we are live. Hello, hello, Microsoft Learn. We are going to talk to you today about building a custom HTTP API with Azure Functions and Cosmos DB. It's really cool to be finally online. It's been a lot of preparation work for those 4 sessions. We are going to have 4 sessions. We'll show you the times and the location where you can find that a little bit later. For those of you who are watching us on Learn TV, if you want to have some interaction, you can join us on Twitch, and we have a link coming up to you in a moment. So it's twitch.tv/Microsoft Developer. This is where we have the chat. And by the way, since I'm mentioning the chat, I also want to mention that we have moderators who are going to be able to answer the questions for you and helping you. And then after that, they are going to pass us some questions as well. Hello, Johan. How do you feel today?
Hi, Laurent. I'm very excited to be with you for this session today.
Absolutely. I'm very excited too. So why don't you introduce yourself and tell us a couple of words about yourself?
Sure. So hi everyone, I'm Johan and I'm part of the cloud advocacy team in Microsoft. I work mainly with JavaScript today, so I'm fine to be with you today.
Perfect, excellent. And you're going to be our expert because I'm more of a .NET person. My name is Laurent Bugnon. I also work with the cloud advocacy team. And I really want to give a hat tip to the Microsoft Learn team who has prepared this session, who really helped us all the way to prepare for this presentation. They are going also to do the moderation. And since this is a live session and we are really, hoping to hear from our viewers, right? So don't hesitate to tell us more about what you're doing, what kind of projects you're working on. Are you totally new to Azure, or do you already know something about Azure and just want to learn more about serverless functions, Cosmos DB, HTTP APIs, or anything else? We really love to hear from you. And also, as I said, don't hesitate to ask questions because we have our moderators who are going to help us, René, and Chris, who are going to do all they can to answer all your questions. They are going also to pass us some questions from time to time. So that's going to be super exciting. So our session today is about building an HTTP API, and we'll talk more about what it means and exactly how it works, and we'll talk about Azure Functions, Cosmos DB, but before that, we are going to go through some theories and understanding why we are actually choosing those technologies. The level for today, this is quite important, it's between beginner and intermediate, right, Johan?
Yeah, so basically we'll show you like a sort of prerequisite to follow along these sessions, but don't worry, if you're just starting, you're fine. If you already know a bit of JavaScript, that will be enough just to follow along these sessions.
Exactly. This is really cool. And we are going to use, I believe, TypeScript, but actually today we are just going to do a small example of Azure Functions. So in terms of code, it's going to be minimal. In the few next sessions, then we are going to dive deeper and build the actual APIs that we are going to do. And again, this URL, if you are following us on Learn TV, this is absolutely cool. But if you want to interact with us, don't hesitate to go to the twitch.tv/Microsoft Developer, and this is where you can also interact with our moderators and interact with us as well. So let's talk about the products, and we are just going to mention a few things about those. Azure Portal, why do we have to use Azure Portal?
Yeah, basically Azure Portal is the entry point for every Azure services, and since we are going to present a few in this session, so that will be like your entry point to all Azure.
Perfect. And we could also do what we are going to do with other possibilities, things like console interaction, command line interaction. We have shell, we have bash, etc. But the portal is a good entry point, especially when you're new to Azure. Azure Functions, we'll talk way more in details about that later. Visual Studio Code, because you can also develop locally, not just in the portal, right?
Yeah, so we'll see that more in details in the second session, not in this one, as this one will be mostly focused on the services, why and how we will be using them. But yeah, just we mentioned also Azure Portal. Visual Studio Code is also nice because we have all sorts of extension for Azure. So if you don't like using the web UI of Azure, you can also do most of the work directly in Visual Studio Code.
Okay, perfect. And Cosmos DB, this is our NoSQL database. Again, here in this particular session, we are not going to talk about it, but later when we talk, I think it's in session number 3, then we are going to connect to Cosmos DB. Prerequisite for you, our dear viewers, we need you to understand a little bit about web development, okay? And especially we are going to use JavaScript. We'll see that you can also do most of what we are going to do, or all we are going to do really with .NET or with other languages, but here we will use JavaScript. Be familiar with HTTP verbs, okay? We are building an HTTP API. We need you to understand what is a GET, what is a POST, what is a delete, these kind of things. Ability to navigate the Azure portal. So if you have never started the Azure portal itself, you might be a little bit confused by what we are showing you. So it's better if you have already started that. Understanding how Visual Studio Code is working. As Johan mentioned, we're not going to use it in this session, but in the next one, yes. And understanding also something about architecture, like why do we say that maybe you shouldn't use a monolithic architecture, maybe decoupling your services would be probably better. So much for the requisites. Oh, and finally, understanding a little bit about NoSQL database. We'll talk more about Cosmos DB in session number 3, which is going to be next Monday. But just so that you understand a little bit what it is and what is the main difference maybe to an Azure SQL database, for example. So the scenario today is a back-to-school scenario, and it's actually appropriate because I don't know for you, Johan, but here in Switzerland, kids are back to school and they need to shop, right?
Yes, I'm in France. It's always that moment like you have to rush to buy all the supplies needed by the school.
Very stressful, right? And so thankfully we have some websites to do that. So this is cool. And the school supplies shop, of course, works pretty well for all the year, right? This is something they have on-premise, meaning they have their own server, and it's about at 70% utilization, which is good. So they are kind of wasting the 30%, right, most of the year. But really, during the back-to-school times, then suddenly there is like literally millions of developers hitting the shop. And then, as you see, now the server is really reaching its capacity. So what do you do now? Well, you go and buy another server, but that can be very difficult because it can take literally weeks until the server arrives. And then you have to set it up. And then this server is not going to be used for the rest of the year. So that's kind of wasteful and not great. And part of that is because everything is running on the same server. So it's a monolithic architecture. You have things like the database is on the server, and then you have all the shopping cart system is on the server as well, and all the lists and everything really. And of course, it's a little bit difficult to check out like how can I maybe give a little bit more power to the interface and less power to the database, for example, or vice versa. So of course, this is going to be a little bit tricky, and this is why we want to try to improve. And to do that, we are going to use a cloud-based architecture. That's the first thing. So we are going to take advantage of the cloud and of the almost unlimited resources, I would say, that we have in Azure. And we are also going to modify the architecture to have something layered and decoupled. So that's going to be quite exciting. As you can see here, we are going to pass quite a few of those services in the cloud. And that's going to help us tremendously. And we are going to build an API over HTTP. So why don't you tell us a couple of more words about that?
Yes, the idea is that we take all the API layers that were previously on our monolithic architecture. All of our application was running on the same server, including the clients. Now our server will only be running the clients, and the idea is to move all those services to a dedicated API layer that we will that we will send requests to over HTTP. So basically, this API layer will be running in the cloud. That's the idea. And it will be able to scale. That's one of the things that we want to solve from our initial problem. And we'll only keep our initial server just to run the client application, the web app. And everything, all the logic, the shopping cart, the inventory system, the database queries will be running directly on the cloud, and everything will be completely separate from the web app.
Okay, that's really cool. And using HTTP for these kind of things is very common these days, right? It's I mean, you know, I'm relatively long-time developer, not to say I'm old. But some time ago, we were using things like, for example, Windows Communication Foundation with a very complex protocol over XML called SOAP, and that was kind of very heavy. But these days, really, we tend to go into what we call sometimes a RESTful architecture, and we'll define those terms later. And sending everything over HTTP, that's one thing. HTTP, right? The second T being a text, hypertext transfer protocol. So we need text, and JSON is a good format for that. So that's what we are going to use here. And basically, this is what our functions are going to prepare and return, right?
Yeah. We'll see that a bit later, I think, especially what we want to find out is what will be the best service. There's a bit of a spoiler here because like the solution we'll be talking more in details is already in the title of the session, but we'll focus on why. Yeah, we'll focus on why we should choose this service, what are our different options, and like define our requirements and see what fits best.
Exactly. Very cool. Very cool. All right. So this is kind of what is the point of those sessions, moving things to the cloud and basically building this API. And, really one thing which is really important and which is really handy, I would say, with the cloud is that you don't have to worry about those peaks anymore because, first of all, the cloud is able to absorb, I would say, the demand, right? Because we are going to scale up, and we'll see later what it means: scale up, scale out, etc. But also, we are going to optimize the spending because you're paying for what you use. And so if you consume more of cloud resources, you're going to pay more. But at the same time, when the demand disappears, which eventually it does, right? When people are finally stocked up with their pens and pencils and everything, then you're not going to pay for what you actually don't use. And so this is an interesting scenario. But really, the cloud scaling capabilities, this is kind of the key advantage here for us to move to the cloud. And that's why it makes sense. Now, we already have some work done. So let's talk about that a little bit. Can you tell us more maybe about the website?
Yeah, basically, for our scenario, we want like you said before, we want to split our monolithic architecture into various pieces. One of these pieces is the website. So we already refactored everything into an Angular application. So that part has already been taken care of. Okay. The second thing is the database. So you told in the introduction that we will be using Cosmos DB. So the setup of the database, the schema and everything, the form of the data we want to use already has been taken care of.
Okay. So we have basically a team which is handling that, right?
Yes, we already have other teams working on that. So we really want to focus on this session on what's needed to build the HTTP API. Especially this session will focus on what service is really best for our current use case.
Right. Okay, so I was a little bit late in the slides, but Cosmos DB already done. HTTP API, not yet. This is really the focus for today. And then we'll also see in session number 3 how we can interact with the Cosmos DB, which is already prepared. So that's pretty cool. So let's do a quick demo of the website, if you allow me. So I'm going to just go to the page. And for those of you who want to try it out, you also have the possibility to go at this address, which I'm sure our moderators are going to put in the chat so that it's easier for people to go to. And this is a very simple website, as you can see. So let me show that to you. Here we go. This is a website. Now, one thing which is interesting is that it's actually running, for those of you who know what is on the screen right now, it's actually running as a static website, which means that for this simple website, we have removed all the server-side intelligence from the equation, right?
Yeah, this is basically just JavaScript and HTML running in the browser.
Okay, so that's cool. And then we have, of course, some APIs to answer to the demands. And so a few things you can do here. You can see the list of products, right? You can go and see a specific product. And here you can also edit. But by the way, just so viewers know, at this address here, we have actually protected our database, meaning that everything that you edit is not going to be saved. But if you deploy the solution yourself, and this is actually here that you can see that. So here you have the code sample, and again, this is a URL that our moderators are going to put in the chat. Here you have the possibility to take this solution and deploy it yourself, and then you have the possibility also to edit everything if you have done that. So this is a website that we are going to now modernize, I would say, by moving the APIs to the cloud. And let's go back to the slides to talk about the learning point that we want to have in this series, the learning objective, if you wish. So first of all, we are going to talk about the API backend. All right. So that's kind of the focus today. And we are going to understand what is a function, why do we even choose that? And then in the next session, which is, next Friday, and we'll show you the exact date at the end of this presentation, we are going to talk about local development, right, Johan?
Yeah, we'll present you all the tools you need so you can develop with Azure Function locally on your machine without even needing an internet connection. So even if you're offline, you can just test everything locally. We'll show you all the plugins, all the tools you need to install and set up for doing that.
And this point of being able to develop the function locally is really a very, very nice point. It's, even before I joined Microsoft, I used to like the development environment, the development tools. We have Visual Studio Code. You can do the same on Visual Studio, like the full-blown if you're on Windows. Visual Studio Code, you can also do that on Mac and Linux, so this is really convenient. You can even install, if you want to try the database locally, you can install an emulator for Cosmos DB. We are not going to do that in this series, but you can also do that. So you really have the possibility to try everything locally before you even deploy. And then in the next session, which is going to be Monday in a week, we'll talk about bindings. And bindings are a mechanism where you can interact with input and outputs, right?
Yeah, it's made basically to make your life as a developer very easier to manage everything you need when you need to read and store data from Cosmos DB.
Right. And this is really going to be very easy. We are going to see that by simply adding a few declarations, I would say some meta information, then suddenly we'll be able to interact and really take advantage of Cosmos DB with minimal code. Okay, so that's going to be really cool. And finally, in the last session, we'll talk about deployment. Can you tell us more about what we'll do here?
Yeah, basically we'll see how to take the code we've just developed for our API and then put it in the cloud running and see it in action like as the final product for the application you just showed the demo for.
That's really cool. And we are going to use some automated deployment like you should, right?
Yeah, we will be talking a bit about continuous integration and continuous deployment in this section also.
Perfect. So that's going to be quite exciting as well. I do love those pipelines and they definitely make my life easier. So that's cool. Here we have some resources. So again, the repository that I just showed you, if you go there, this ak.ms link that our moderators are going to also put in the chat. This is where you can find the solution, the source code, and you'll find also the finished solution, meaning the solution that we are going to show you after 4 sessions. If you want to deploy it yourself. And finally, there is also a learn module, and we'll see that a little bit later. We are going to, over the course of those 4 sessions, we are going to do a little bit of also interactive work, like exercises and hands-on and all that. Now, if you feel that you're a little bit overwhelmed and you cannot follow as we go, don't worry about it. You can also do that later. But the cool thing with the learn module is that you can try things out even if you don't have an Azure account, right?
Yeah, basically the nice thing about going to this learn module is that you can just create all the Azure resources needed just to try out and test everything we'll show in this session. Even if you don't have your, as you said, your own Azure account, there will be everything provided for you and for free.
That's really cool. And we are going to use a system that we call the sandbox, all right? And you'll see how you can activate that and do everything there. And the sandbox means that those resources are going to be created for you for free. You can use them for a while you are doing the exercise, and then they are just going to disappear. Now, obviously, if you have an Azure account and you want to use that instead, you can also do that, and then you can just map what we are doing. So this is a Learn module where you can check all that. And again, we'll come back to that when the time comes for the first exercise. So this is the first session of 4. What are we going to do in this particular session is talk about the different Azure services that we have, different options that we have. And then finally, spoiler alert, like you said before, Johan, once we decide that we will use the Azure functions, we are going to show you how you can create your very first HTTP API based on a function. You can also do other things with functions like we will see, but that's kind of the goal today. And hopefully everybody will be able to follow that. So how do we choose the best Azure Compute Service. Maybe we need to quickly define compute. It's basically something that runs on Azure, which is going to perform an operation, something like that, right? So how would you go into finding the right service?
Yeah, basically, we'll first try to define what will be the requirement for this project, and we'll see that, I think, in a few slides. Yes. So yeah, you can stop. Sorry. You will see that in the few slides. So basically, we'll first speak about what we want for our project, and then see how the different services we already have at hand in Azure match our different requirements, so we can choose the best solution that fits our use case.
Perfect. So let's talk about that, and let's see how those project requirements are coming, and then we'll talk a little bit about the architecture. Again, the goal here is not to basically make everybody become an architect, right? But this is important even when you are a developer, even for a junior developer, to understand some of the concepts and maybe why architects like to select specific architectures rather than others. So let's talk a little bit about those requirements. The first thing is that we want to implement an API. And why an API? Well, we don't want to be monolithic anymore. We would like to spread things out, and an API, an application program interface, is a good way to do that. So that's the first requirement that we want to do. And we would like people to use a development language that they know, and the firm already has some JavaScript developers, right? Because they have an Angular website, so they kind of know that already, right?
Yeah, that's why I think the best thing will be to choose JavaScript. More precisely, we will be using TypeScript for this project.
Oh, interesting. And we'll talk more about that, and we'll understand why TypeScript rather than JavaScript. Well, vanilla JavaScript, what people sometimes call. And so we are going to use also Node.js as a server-side component, right?
Yeah, Node.js will be the platform we'll be using for the tooling, but also for running and executing the JavaScript code that will run later in the cloud.
Okay, but the good thing is that when you deploy in the cloud, you don't have to worry about it because it's just taken care by Microsoft in that case, right? So, yes. But again, this is going into serverless. We'll talk more about that a little bit later when we talk about functions. Another thing is that our team, the client's team here is totally overloaded with other things. They want to improve the website. They want to build maybe a mobile application or something. And they really want to not have to spend too much maintenance effort. So what we see here is kind of something which is typical of the digital transformation that we have in many enterprises, where the roles are shifting a little bit. Instead of having some people who are full-blown server administrator, then maybe they are going to shift into more of a maintenance role of something which is basically managed by Microsoft in our case, or by whatever cloud providers they want. And then they can also use some of their skills to improve other things. And it doesn't mean that their whole infrastructure is going to be online, but by moving some of the infrastructure online, they can reduce their maintenance effort, right? So that's a good thing. Another thing is the peaks. We have talked about that, right? When we have the back to school, we need to be able to absorb the demand. Okay, so that's
and I think yes, scalability is also being able to scale to the demand appropriately is one of the many reasons that people choose to move to the cloud instead of using on-premises servers. Because as we saw in the introduction, already if we wanted to upgrade, we could just like buying a new server, but maybe the year later we'll have to buy a new one, and that will only be for like absorbing the peak demand of the back to school season, while like the rest of the year will be paying for nothing because it will be like underused. Sorry. So basically, to be able to scale up and down is one of the major reasons we choose to use the cloud here.
Yeah, this is so true. And that's what I always say when I give a presentation about Azure in general. I say, scaling out is important, but scaling in is equally as important, right? You don't want to pay for things that you don't use. And that's really a very interesting feature that we have in the cloud. Another thing is cost, all right? Cost is always something that we need to take care of. And so it kind of goes hand in hand, right? The peak and the cost. If we have some features, some resources on the cloud that we don't use, we can switch them off. Or in the case of serverless, solution that we'll talk more about in a moment. It just happens automatically. So it is, of course, interesting from a cost perspective. So this is kind of the most important requirements that we have. And so let's start talking about those Azure compute services. What kind of things do we have? And we are going to use some acronyms. So let's define those acronyms quickly, and then we'll go much more in detail for each of those. First of all, IaaS, and we always hear this AAS, right? As a service. It's almost a meme, right? You get some coffee as a service if you, if you work in the cloud like us, right?
Yeah. So this one is infrastructure as a service. You may also have here the term virtual machine. It's the same thing. So we'll go into the detail of every of these services a bit later. So let's review all of them at once.
Cool.
So we also,
Then we have platform as a service, right?
Yes, PaaS.
Yeah, so PaaS, platform as a service, which is kind of a little bit like an evolution almost, right? The next stage. And then maybe you have also containers. And again, we'll define that more in detail in a moment. You may have heard the word Docker or maybe sometimes Kubernetes, these kind of keywords which are associated with containers. And then serverless, or sometimes called functions as a service or something like that, where we really concentrate on the functionality and not so much on the infrastructure. So I would say let's dive in, okay? It's a good time to dive in. So let's talk about infrastructure as a service. And what do we see here? What is happening here on the screen?
So the idea is why we should use infrastructure as a service. What's the best use case for that? Mm-hmm. So if you just move forward to the next animation, yes, the idea is that it's a bit similar to what you already had if you had on-premises servers, but basically you just remove the hardware from the equation. You move you let your cloud provider, in our case that will be Azure, to take care of all the hardware, all the networking, the security, and things like that. And you will manage only all the software. That means that you also have to take care of installing all the OS, the operating system, managing all the updates and things like that. You also have to manage your runtime, to install all the tools you need for developing in the language you want. And you also have to install your application manually. So that's a good use case for migration scenarios. Basically, if you're doing lift and shift, that will be what you want to use, but it's maybe not suited for what we want to do there, as we're starting fresh with a new application from scratch.
And we'll talk about lift and shift in the next slide, but I stayed on this slide because I wanted to mention a term that we use often, which is called the shared responsibility model, that we have a lot in the cloud, where basically every time you publish something to the cloud, you're going to enter a shared responsibility model with your cloud provider. And what it means is that the cloud provider is going to take advantage of certain aspects of your application infrastructure, and you are going to take care of the rest and to be responsible for the rest. And so in the case of a VM, for example, you have your virtual machine running. If you don't put, for example, an antivirus system on this machine, then that's your responsibility, and maybe your machine is going to get infected. In fact, I think we can say it is going to be infected as soon as you put it online, pretty much. So this is your responsibility to take care of that. So it's good to understand this shared responsibility problem. And so use cases for IaaS, you mentioned lift and shift. Can we maybe define that a little bit like more in details? What do we do here?
Sure. Basically, we could have done that. For example, if we wanted to take our monolithic application and just take it like it were running on our on-premises server and move it to the cloud. If we wanted to do that without refactoring or recoding anything, we could have used a lift and shift. That's exactly what it means. We take all our software and we move it in a virtual machine in the cloud.
Excellent. And so that's often a first step into the cloud, because of course that's something that people can do, I would say, relatively easily without having to change too many things in their infrastructure. It is a good scenario when you need the full control. Let's say that you are using, for some reason, a relatively old version of Windows, which is not offered in the marketplace, in the Azure marketplace that you cannot choose, for example, or an old version of SQL Server because sometimes it happens, or you need just the full control over your operating system for some reason, and also scenarios of big data. Now we have some platform as a service offering for big data as well, but maybe sometimes you need to massage your data in a specific way, or you need to do some special operations on that. So it's also one scenario which is possible. So IaaS, I think we have understood a little bit better what it does, but let's go through those points. Would you use IaaS for what we call sometimes a greenfield project, like a brand new project you're starting, and then you decide, well, maybe I will go into a VM, for example? Is that something that you would do?
Yeah, not really. As I said, it's best, I think, for migration scenarios. So I don't think really it fits our use case here.
Right. Supports JavaScript and TypeScript. I mean, yeah, it's a VM. Yeah. You can run whatever you want, right? So that would be okay. Low maintenance, definitely not, right?
Yeah, you have to take care of the OS, you have to take care of the runtime, you have basically to take care of everything and all the updates yourselves. So that's not what I call low maintenance.
No, absolutely. And can it scale efficiently? And I guess the key word here is efficiently. So yes, you can scale by, replicating your machine and having a second machine or a third machine, but that's going to take minutes until it's done, right? And so maybe it's not the word efficiently that we are looking for here, right?
Yeah, it's not the most easy way to scale. Definitely.
Correct. And cost efficiency, I think we can say that it's not the most cost efficient because even though, you're going to delegate some of the responsibility to Microsoft and not have to worry about networking, etc. The problem with VMs is that they are hard to optimize. You are not going to run them to your capacity, to the full capacity. And if you scale up, you can also, or if you scale out, you can also, of course, scale in later. That's okay. You can even do that in an automatic manner, but it's going to take a while. And during that time, you're going to pay for the machine, even if it's underutilized. So it's probably not the best, the best usage for our money here, I think.
Yeah, I agree with you here. Probably that we have better solutions suited for that.
All right. So let's do a quick quiz. And so for this quiz, I will ask the viewers to put the answer in the chat. And I'm just going to read the questions, or at least mention them, because just, if we have some people on the call who maybe have some difficulties reading. So what of the following scenarios, which one would be a good IaaS candidate? So for example, every time that you update an image to a blob storage, blob is our storage system. A blob is something like a file, if you want. So every time that you upload a file, an image, you want to run code every time. That's solution number one. Taking an existing server which is running on your premise and then moving it to Azure, for example, a complex booking system, maybe some legacy systems. Number three is hosting a service component of a microservice architecture. And number four is deploying a new shopping website based on ASP.NET Core. So just a few seconds for the viewers to answer. And I think we can, without too many surprises, based on what we said before. Which one do you think, Johan?
Not sure. I think 2 might be the correct answer here.
I think 2 is correct, indeed. And so again, right, it doesn't mean that you cannot do the rest using VMs, but it's not the most efficient way to do that. You could totally host an ASP.NET Core shopping website on a virtual machine if you want to, but it's definitely not the most efficient. On the other hand, if you have a complex system, maybe with some legacy component, moving it to Azure in a lift and shift scenario is probably a good thing to do in a VM and in IaaS. So like I said, very often the first step in the cloud. So that was pretty much what we have about IaaS, and now we can move to the next step, right?
Sure, let's go ahead.
Let's go ahead. So the next step would be Platform as a Service, PaaS. So here too, maybe you can tell us a little bit more about that, Johan?
Yeah, sure. So in Platform as a Service, basically the idea is that you manage less things. In the previous solution, we saw that you still had to manage the operating system, the runtime, and everything. This time, the only thing you have to take care of is your application. You provide your application, and basically your cloud provider will manage everything. That means in everything, I mean like the storage of your application, the runtime you need to run your application, whether you're using Java, .NET, JavaScript, or whatever is your favorite language. It will also manage the operating system for you and the associated update and security. So basically, you can really focus on the application you're building.
Yeah, that's really cool. And again, right, using these keywords, the shared responsibility model, here we see that clearly there is way more responsibility in the cloud providers box, and which means that there is less responsibility, also less risks on the client, on the users, in that case, the developers box. And so that's pretty cool. And also one thing that we can mention, which is really important in platform as a service, is that you can also take advantage of the fantastic monitoring solution that we have. Azure has a very extensive monitoring solution called Azure Monitor, which allows you to check pretty much everything that's going on. Now, this is also available for VMs, but you see the problem is that on a VM, if you want to instrument and monitor the inside of your VM, that's your responsibility and you need to instrument your VM yourself. On the other hand, on a platform as a service, since the web server is running in the responsibility of Microsoft, we are going to monitor it and we are going to provide you with all this data. So this is a good example to understand a little bit this shared responsibility service. So what would we say platform as a service is good for?
In my opinion, there are good use cases for platform as a service, like building a new web API application. It can also be used for example, storage services that you want in the cloud. If you want to use database as a service, that's also another acronym. But yeah, it's a good use case. If you want to build a backend for your mobile application, that's all kind of scenario that would fit well for platform as a service.
Yeah, that's really cool. And I like that we mentioned database as a service. As a service is a little bit played out now. We need to find a better acronym than that at some point. But the databases that we have, be it Azure SQL database, be it PostgreSQL or MySQL that you can run on Azure database as well, or the NoSQL solution with Cosmos DB. This is really as a service, right? It's again a scenario where you say, all right, I don't want to worry about my SQL server. I don't want to patch it. I don't want to always have to install the newest version, but Microsoft is going to take care of that. And then you can concentrate on the important thing, which is the data, because this is really where your enterprise, where the richness of your enterprise is available, and also where your expertise is more valuable because you know the data and you're going to provide a specific service. So a great description of the use cases here. So again, let's go to this list and let's talk a little bit. What would you say about new projects?
I think PaaS is really fine for new project. Like I said, if we're building a new web API or if you want a mobile backend, that would be nice to use that.
Yeah, I totally agree. And in fact, I'm routinely, very often, it's like when you buy a new custom domain name, because you know what, that's what we do, right? We accumulate custom domain names and then we need to make them live somewhere. And then we will create a platform as a service website, most probably. Does it support JavaScript and TypeScript?
Yes, definitely. We can use all kinds of language, and that includes, of course, JavaScript and TypeScript.
Yes, and for those of you who are in my field, .NET as well, right? So this is really cool. We have ASP.NET. We can run also on one thing which is quite interesting to know is that you can run also those web applications on Windows Server or on Linux Server if you want. So if you do ASP.NET Core, or of course, if you do TypeScript, JavaScript, that runs as well. So you have a choice here. Low maintenance overhead. What would you say about that?
I would say it's definitely better, as we just saw, that using a virtual machine, but it's not like an all automatic solution, because for example, if we are talking about Azure App Services, which is one of our PaaS offering, if you're developing JavaScript application, you will still have to upgrade manually, choose the right runtime, the right Node.js version you want to use, and it won't update it for you. That's best also, but basically you still have a bit of maintenance over time just to manage your application.
Right. So it's yellow, meaning it's like in between, better than VMs, but maybe not the the best solution we can take.
Yeah.
Scaling efficiently to handle peaks.
Yeah, it scales better than VM. That's for sure. But still, even if you can set up some automatic rules, that still won't be the most efficient solution for our scenario. I think we can still do better because it will take some time just to scale up and down, and it won't be as efficient as some other solution. We'll see better just to absorb peaks.
Right. And again, right, the keyword here being efficiently, don't get us wrong. You can absolutely scale up or scale out using app service, using platform as a service, but it just requires a little bit more configuration, and maybe it's not as efficiently handled or as transparently handled than with other of our solution. Cost efficiency, what would you say?
I would say still it's better than VM, but as you said before, it goes hand in hand with the scaling. So as long as it can scale efficiently for our use case, it won't be the most cost-efficient solution for our particular use case here.
Yeah, I think this is correct. So here we see that we have a picture which is better than the VM, maybe not totally optimal for what we are trying to do. And so here again, a quiz question. So again, I'm going to go through, bear with me, it's just so that, if some people have difficulties reading, which of the following scenarios would be a good platform as a service candidate? First of all, running the code every time an image gets uploaded to an Azure Blob Storage, basically the same as before. So the Blob Storage scenario where we want to process something like extracting, location information from a picture, or maybe running the picture through an image analyzer to recognize the picture. Number two is move an existing on-premise server running a complex booking system. This one we kind of know that it's not that because we said it was good for the VM. Number three, hosting a service component of a microservice architecture. And number four, deploying a new shopping website based on ASP.NET Core. I think that without too much suspense, we can already predict that the answer would be, what do you say, Johan?
I would say 4.
I think it's probably a good choice here, indeed. So if you need to deploy a new shopping website based on ASP.NET Core or based on Node.js, or we also support Java, we support Python, we support PHP, we support all kinds of things, then probably, even if you started fresh with a new project, using app service and using a platform as a service scenario is probably a good idea. So let's move on now and let's talk about containers. And here I see a cute little whale. What can you tell us about this whale? What does it mean here?
So this is the Docker logo. So what are containers? Containers are kind of lightweight virtualization system for running application. It's a bit different than VM because you don't have to simulate hardware. You don't have to have a full operating system in different parts of the blocks you want to run your application on. Basically, you just take your application, you take the runtime you need to run your application, and you put it in a box, a sealed box that's called a container. And that's the container will run on a host system, just like a VM. You can have multiple containers running on the same system, but it will be definitely more efficient than using multiple VM because you won't have to emulate all the hardware. You only, every container will run on the same kernel, on the same operating system, and will share all the resources.
So, that's interesting. So this is cool. So maybe we can talk a little bit more. This word kernel and all that, this is, for me as a newbie to containers, almost a little bit scary because, it means like going pretty deep into the machine, right? But the cool thing with Docker is that I don't really have to worry too much about that because Docker is going to take care of a lot, right?
Yeah, that's exactly it. With Docker, you will be able to create images. Basically, you define what you want to put in your container. That will be all the tools you want to install and your application. And it will create an immutable package that is ready to run wherever you want. So basically, one of the nice things in Docker is that you can test it locally on your machine and take it as it is and deploy it the same container on the cloud.
Oh, that's cool. So it kind of answers the, it works on my machine, sentence that we always have as a software developer, where here you can say, well, it's not just on my machine that it works, but I know that in the Docker runtime, it's going to work. It's been tested, and then we deploy that to, for example, to Azure. We have, of course, container environments on Azure, or you deploy that to an on-premise server with a Docker runtime, and you know that it's the same runtime, so it's going to work. Now, one thing which is worrying me a little bit in this picture is that those containers, you're going to have multiple containers in the same physical machine, right? So isn't there a risk? Like, how isn't one container going to be able to access the data of another one, for example?
No, that's one of the great things with containers is that every container is completely isolated from the other. So there's security mechanism that prevents you from sharing data between containers. So basically, it's like running every application in a different server. But in that case, with container, you can do it on all of that on the same machine without the issue of data leaking to one another, because everything is completely isolated in your own container.
Oh, fantastic. So that's interesting. And you can run those containers on Windows machine or on Linux machine, right?
Yes.
Yeah, that's cool. And I believe that on Linux machine, it's a little bit more optimized because of some features of the kernel. On Windows machine, it's a little bit different, but basically you still have a choice. And if you need absolutely, for some reason, to run a container environment on the Windows servers, this is possible to do that as well. So now we understand a little bit better what containers are. What kind of use cases do you see for that?
Yeah, you probably already heard about microservices because that's the buzzword these days. But the containers are the recommended use case, are the recommended solution for that particular use case. So microservices is when you have a lot of different completely independent services that you want to deploy, you want to develop, and you want to evolve completely independent one of the others. You want to also maybe to be able to scale each one of these services independently. So that's a good use case for using container. But that means that it's not a self-running solution like PaaS, for example, because you need to orchestrate. You need to have some sort of management solution for all of these services to be able to deploy them, to be able to scale them, to be able to manage all the updates or the rollbacks if it's needed. So that adds a bit of complexity. So I'm not sure that will be like the most efficient way for our current use case, because what we want to do is quite simple, but it can be really useful. For example, if you have a company where you have different teams working on separate parts of one big application, that can definitely help.
No, that's really good to know. And one thing I wanted to mention is that we have an interesting hosting scenario, because you mentioned that one of the features of containers which are really cool is that they are immutable, right? You can kind of seal them and say, all right, they work on my machine and I know they are going to work. And one thing which is cool is that you can also host a container, a web application running in a container in app service. And so you kind of have the best of both worlds. You have kind of a mix of containers and platform as a service, right? And so that's also something which is interesting to know. If you deploy a website to an app service, which is a platform as a service, you can deploy it as code directly, or you can put everything in a container and then run it inside the app service. So it's also a good scenario. In that case, of course, you don't have management and orchestration. It's just taken care of by the app service. I mean, you still have to manage. You don't really have orchestration because you're going to have just one container. But really, I think very often we hear the word container associated with microservice. It's kind of what we hear. So let's go into this list again. And what would we say? Container for new projects. Would you do that?
Yes, definitely. That should work depending on your use case.
Yeah, it depends on the project, right? That's absolutely true. Does it support JavaScript and TypeScript?
Yeah, because like a VM, you can install whatever you need in it. So it supports what you need for your application, and that includes JavaScript and TypeScript.
Cool, very cool. Low maintenance overhead?
I wouldn't say so, because while it's definitely better than managing VM and their OS updates, you still have to configure and use an orchestrator to manage all these containers. So basically, that needs a bit of maintenance work.
Yeah, and you need also a little bit of skill, right? It's not immediate. You don't like immediately translate your developer skill to a management skill, so it's a little bit tricky. Scaling efficiently to handle peaks. What would you say about that?
I will say that's definitely one of the use case supported by containers, but again, it needs some bit of tweaking and manual configuration so that works efficiently.
Yeah, and then here one keyword could be Kubernetes, for example, which is really an orchestrator system where you can configure it to automatically scale up and scale out. But of course, the problem being that you need to know and understand a little bit what is Kubernetes, how do you set it up. And so this is why here we say it is definitely efficient, but maybe not as efficient as other possible solution. What about the cost?
I would say if you already had an infrastructure existing with many containers already running, that might be a cost-efficient solution. But for our particular use case here, we have a lot of everything you need to set up, including a Kubernetes instance, for example. So that may not be the most cost-efficient solution here.
Okay, very cool. So let's go into a quiz, and which one of the following describes a container the best, right? So an immutable package, we hear again this keyword immutable, that contains everything you need to run your application, right? The system package, the binaries, and all the libraries that you need. Number two would be a package of an operating system together with the application code that you want to run, so the full operating system here. And number three, a set of commands that builds our application on the host system that we deploy it to. And what would you say is probably the best solution here?
I think from what we just said, the first answer will be the right one.
I think so, right? So it's an immutable package, this keyword immutable, that contains everything you need, but not more than what you need. And I think that's the main difference with a VM, where you have also tons of things that you're not going to use. So this is a good understanding of what is a container. Now let's move on to the next stage. And now we talk about serverless computing. And so that's interesting because where is the server here? If we don't have a server, where does it run, right?
Yes, serverless is like a bit of a common word because there will always be server running your code. That just means that you won't be the one that will manage it.
Yeah. No, totally. It's a running joke. There is definitely a server. So, we kind of joke about it. We say serverless doesn't mean no server. It means less server. The server is still here. The really key feature here is that you don't need to manage this server yourself. So it's kind of removing the infrastructure headache from the equation. And so what are the main aspects of serverless computing? So infrastructure, right? Or rather less infrastructure.
Yeah, but basically you won't have to take care of provisioning the resource you need. That will be like the VM if you were using IaaS. That will be setting up all the services and the configuration needed to scale it if you were using platform as a service, or setting up an orchestration solution if you were using containers.
Correct.
Basically, you don't want you want to have a minimal setup just to run your code.
Yeah, and resources, that's going to be efficient mostly because you're going to pay for what you use and you're not going to pay for anything more.
Yeah, that's one of the best things with serverless is that it's like built for very efficient use of the resources. It's able to scale very quickly. That will be up and down, so it's really meant to absorb some peak demands as you need.
Yeah, and one important aspect of serverless computing is that it reacts to events. And that's important to understand because it also helps to understand why it's cost efficient. It's because most of the time these applications, right, this code, or in the case of Logic Apps, we don't even have code, but there is always code somewhere. This application is going to be mostly sleeping when it's not used, which means that you don't pay for it. And then an event happens, and we'll talk more about that when we talk about triggers and connectors and all that. Something happens. It could be a timer. It could be an HTTP request. It could be all kinds of things. And then the code kind of wakes up and starts, right?
Yeah, exactly, and that's basically what allows serverless to be very efficient because thanks to this solution, there's this micro billing. You only pay for what you already use.
Mhm.
If nobody calls your API, you won't be paying anything.
Yeah, and when we say micro billing, we mean micro billing. We bill, by the seconds, right? So it's not even minutes or whatever. It's really for what you use and not anything more. So those are like important aspects of serverless computing. So we understand serverless computing a little bit better. Let's talk about the list again. Would you recommend that for new projects?
Yeah, again, that will be depending of your use case. That will be really an interesting solution for new project.
Yeah, exactly. And, we have serverless solutions on Azure. We still don't know exactly which one we are going to choose because, again, there is a choice. But do we support JavaScript or TypeScript on that, or do our developers have to learn a brand new language?
Yeah, we'll see a bit about that more in details later. It depends really on what serverless solution we are speaking about because serverless can be many things. In terms of Azure function, of course, you can use JavaScript and TypeScript, but
Mhm.
we'll see that it's not the only serverless solution that we have in Azure.
Yeah, that's good to know. And we'll talk more about that in a second. Low maintenance overhead, I would say, based on everything I heard, I would say yes, right? We don't have to worry about the server. We don't have to worry about the operating system that it's running on. No networking worries, no other worries like that. This is all taken care of by the cloud provider. So it's probably true. Does it scale efficiently to handle peaks?
Yeah, exactly the main point of serverless is that it's made for that.
It's made for that. Yeah, this is really cool. And really, it scales like instantly. You can see those functions popping up. And when we say scale, we can talk about massive scale, right? I mean, you can literally have thousands and thousands of function instances which get deployed in parallel to handle a huge demand. So very efficient. Cost efficiency, we already talked about that associated with a micro billing scenario, micro billing use case. I think we say it's true. So here we see we have something which is quite fitting for our scenario, right?
Yeah, exactly.
Mm.
Just to mention, when you're looking at this matrix, this is not like an always true matrix. This is very for our own particular use case. We just presented at the beginning of this session, right? So
Correct.
you just don't take it as like a universal solution to all your application needs. For our particular business project, for the API we had, and we wanted to be able to meet peak demand for the back to school season. That really looks like serverless will be the most effective solution for us.
Yeah, no, that's a great thing. And again, right, this keyword efficiently for the scaling, for example, we don't say that you cannot scale using IaaS. We just say that it's a little bit more complex to set up than with function, but you can definitely do scale sets with virtual machines or scale up or out using platform as a service. Still, it feels that we are, going into the direction of a serverless solution to our problem here. And so that's interesting to know. Let's talk a little bit about different options that we have, because like everything on Azure, you have a choice, right? And so what kind of scenarios do we have here? What kind of possibilities?
So if we take a look, we have possibility to use logic apps. We'll
Mm-hmm.
see about more just in a moment, and we have functions.
Functions,
We'll
exactly.
obviously talk more about function, but let's just speak a bit about logic apps here.
Let's do that. And again, we also have additional services that you could qualify as serverless. For example, you can run also Cosmos DB in a serverless manner, or maybe things like Signal R as a service. Here we talk really about relevant services for our scenario. So let's talk about Logic Apps. And can you tell us more? What is Logic App and why do I actually love it? I do love Logic Apps, even though I'm a developer. So what is making it so good?
So the goal of Logic App is to have cloud services to be able to automate your business process, but
Mm-hmm.
not using code, using a graphical design tool that's called the Logic Apps Designer that makes use of pre-built components you use just to arrange your workflow, your sequence of things you need to do for your own process.
Oh, this is really cool. So it means that I can use that, for example, to connect to existing services because I have keyword connector, which is made available for me, right? So this is really cool. And the no-code aspect is sometimes a little bit scary for people, especially for developers who are listening to us now, because they feel that, oh, if I don't have code, I have less control over it. But it's not quite the case, right? Because Actually, there is some code. You can, the logic app itself is defined as a big JSON file. You can put that into source control. You can manage the changes. You can see, and also you can debug it, right? You can see what's going on when you execute the logic app. So it makes it really a very comfortable environment to develop for. And one thing which is also cool to know is that you can totally mix and match. You can totally have an application which is made of a logic app, which is calling a function, or a function which is executing a logic app. There are all kinds of ways to do that. So here is an example of workflow. Can you run us through what's going on here?
Yeah, this is an example application you can build with logic apps. For example, if you want just to monitor, like for example, Twitter, let's say, and you want to be notified if someone speaks ill of your product, you can be able to to pass these tweets and detect if the content in the tweet is positive or not. And for example, if the content is negative, like send an email to the customer service to investigate what's going on, and if it's positive, like save the link maybe to take a look at it later in your database.
Okay, that's really cool. And so this is all happening automatically, right? Because there is a trigger. And in that case, the trigger would be there is a new tweet. And so that's kind of one of the connectors that we have. But we have hundreds and hundreds of connectors. I use Logic App often when I want to gather some information from my colleagues. And so I have something called Microsoft Form, which is a feature, a product of Office 365. It allows me to create forms very easily on the web to compose the questions that I want to gather. And then after that, I send the URL to my colleagues. And every time that an answer is submitted, I run a Logic App, for example, to extract some information and to save this information somewhere else. So again, we have almost unlimited solutions here. That's interesting. And we mentioned triggers, right? So what kind of triggers do we have?
You can have various triggers. For example, be notified when you receive a message from some Azure services like a service abuse queue, or if you see a new tweet on a particular keyword, or when you receive an HTTP request, or for example, also if you can define time-based trigger. For example, to set an alarm or have something running every day at a given time. These are all kind of triggers. I don't know if you know, it's a bit like similar that service for your home automation I used called EFTTT. If this, then that. It works exactly the same thing. You take one of these triggers and you can define all your workflow based on that event.
Exactly. And so that's the trigger part, but we also have connectors, meaning that you can also run different blocks, and then you can also send some information to a service as well. And so, for example, in the case of OneDrive, for example, you could also go and save a file on OneDrive, not just react when the file is saved, but go and save something. Or the HTTP request is interesting because it's a very, very generic scenario. This is kind of a webhook based scenario where you create your logic app, and then you will get a URL, which is a unique URL for that. So basically, it means that we could theoretically implement our HTTP-based API using logic apps, right? It's a possibility.
Yeah, that would work, but it means also that the code wouldn't be like in a repository because you need to use the graphical editor directly on the web.
Yeah, it's a little bit more work. And so let's talk about a couple of use cases. We kind of mentioned that already, but data ingestion is a typical scenario. And since it's a low-code scenario, or maybe sometimes even no-code scenario, it means that also a business person can, start tweaking the logic app without necessarily knowing how to code. So it's kind of interesting for certain scenarios. So transforming the data, ingesting the data, recurring workflows is also something typical that we do in logic apps. You can also do that in functions. So here again, we have a choice. We don't say that one solution is better than the other. We just try to match them to our scenario. And since we have a couple of minutes, I thought that I would give you a quick tour of a logic app that I have. And so here I have the Azure portal, and this is my own subscription. This is my Microsoft.com subscription, as you can see. And so, for example, let's say that I go into this logic app here, And as you can see, I have some information here, but quickly I will go to edit so that you can see how it looks like. So here I have something which happens here. So here in that case, this connector, this icon means it's an event grid, meaning that I'm connecting this logic app to a storage account. And when something happens inside the storage account, for example, a blob is being created or a blob is being deleted, then I'm going to do something. And part of what I'm going to do is some JSON parsing. So I'm going to take here an input, which is, sorry, the data object that I receive from the event grid. And then you see that I have a schema and I define this schema. It's quite easy to do. I'm not going into too much detail here, but simply by passing a sample payload. So the first time that I execute the service, I will get some payload and I just give the sample payload here to this block. And then after that, based on what's going on, I can do something. For example, I can do a post to a service, and this service here is a service that I built using Azure Function. Is going to send a notification to my phone, push notification. But what's really interesting is that I can also add some things, and I can do something which are pretty complicated. For example, I can put here a condition, and I can say, if something is true, then do something, otherwise do something else. Or I can say, well, I want to have, let's remove this one. And I can say I want to have a loop, like a for loop. And then already with if then else and with for each, you already have something which is interesting to build programs, to build applications. Or you can say, all right, I want to have a switch based on the value, etc. So you can also build some trees and some decision trees, some workflow-based trees. So I don't go further into the detail here, but I thought it was interesting to see the designer, how it works. And what's also interesting is that, like we mentioned, you actually have code which is associated to that. So this is the JSON code which is associated to this design here, and which means that you have the possibility to put it under source control. It's just a little bit more tedious and a little bit more cumbersome, I would say, than if you do a fully code-based solution like Azure Function. So much logic.
As a developer, Laurent, I would have a question for you, just based on your example.
Go ahead.
Can you at some point just insert inside like a block with some code, maybe JavaScript or any other language, just for example a simple script, or do something like that on my data? Is it possible to mix in code with all these pre-built components?
This is a great question, and the answer is yes, you can do that, because look at that. If I type Azure Function here and wait until it comes, I can actually add an Azure function inside here. And now we know that Azure functions are code, and we'll see a little bit later how you can build that code and all that. So yes, it is possible, meaning that if I want to have a little bit finer control over the execution of my workflow, I can do that by adding here an Azure function in the process. So yes, you have literally the possibility to combine everything. And by the way, another thing I want to show you, which is really cool, is that you can even do things which span, our competition. For example, look at that. I can even say I want to send an email using Gmail, or save something to Google Task, or to open a Google Doc, or things like that. So we really have a choice. Now, of course, if you don't use Gmail, in my case, I use rather Outlook.com. I also have the possibility to do that. So really tons and tons and tons of possibilities, also things more enterprise specific like SAP, etc. So you have really quite a lot of possibilities here.
That's good to hear.
That's good to hear, exactly. So let's go back to the slides. And so we have understood a little bit better what logic apps are and how they work. But here we have a specific focus and we have some specific requirements. So would you say that logic apps are recommended for new projects?
Definitely, if you're wanting to automate an existing business workflow, that would really suit for that.
Yeah, absolutely. And like you saw before, right, it is great. It doesn't have code. It is going to respond to triggers. So it's very often what we do. Does it support JavaScript and TypeScript? We kind of answered it already, but maybe we can just mention that a little bit more.
Yeah, if we speak about being able to code directly now, because it's a low-code solution, you basically mix and match pre-built components. Of course, you can, as you just shown, you can mix in and call Azure function, so you can write and mix some code in there, but it's not part of the tool directly.
Correct. It's like we would have to create this Azure function application and to deploy it. So it's kind of what we are going to do anyway, right? So, it's not direct support for TypeScript and JavaScript. Low maintenance overhead, I think we can say yes, because we saw that there is nowhere the mention of a server. I didn't have to choose an operating system. I don't have to scale up and down manually. It's going to happen automatically. I just mentioned it. Is it scaling efficiently to handle peaks? I think we can say yes, but maybe not quite as efficiently as an Azure function application, right?
Yes, exactly. Because it's based on built-in components. You don't have this fine control over the code that's running behind. So.
Mm-hmm. No, this is a great point. And finally, is it cost efficient? Well, yes, our serverless solutions are cost efficient. You pay for what you use, but not for any more. And so this is not such a bad picture, I would say, but there are a couple of points where maybe we want to check what functions have to offer and talk a little bit more about that. But before we do that, I do believe that we have a quiz. So let's say that you want to build a jokes website, and you have your jokes in a database. But every time that somebody adds a joke to the database, you want this to be posted to Facebook. So in that case, Facebook, maybe another social network. Can you do that with a Logic app? What do you think?
Yeah, but based on what you just shown us, I would say yes.
Mm-hmm. Yeah, probably, right? You're going to have a trigger which is based on a change in the database. We do have that for Logic apps, and then you have some connectors going to your social networks. So definitely possible. It's actually quite easy to do something like that. The nice thing is that you don't have to handle the authentication to the social networks. This is all handled by the Logic app infrastructure. You're just going to get, the well-known login window inside the web browser when you do your design, and then you can log in. And once you're logged in, those credentials are stored for a period of time. So this is pretty efficient, pretty cool. However, we want to talk about functions because it's even in the title, right? So again, spoiler alert, we told you in the title already, we are kind of aiming at functions. So let's talk about functions now. And what are some really common use cases for function? That's going to be the first thing that we'll talk about. And then we will see an example where we are going to go into a Learn module, Microsoft Learn module, and build our very first function application with a few clicks. I don't know if there are really only 10, I didn't count, but at least we can say that it's going to be quite easy to do. So what is a function? Can you tell us more about that? And what do we see? Like, what does this code even do?
Yes, sure. A function, as you can see here, an example, it's a small piece of code. It's no more than that. And this is code. This function will be executed in response to a particular event. And that event, it's called a trigger, like we saw for Logic apps. In the case of an HTTP function like that, the trigger will be the HTTP request. So this code will get data from the requests, from the URL exactly. It will take the name and just answer some JSON in the body responding hello with the name of the name that was passed in the URL. So basically, we just built a function into an HTTP function in 2 lines of code.
Oh, that's pretty cool. And we see that there is a lot of things which are given to us by the infrastructure. For example, you mentioned the request, right? We know when you're a web developer, the HTTP request is like a critical component that you need to interact with. And for example, the query string, right? This is something that we always need to read, or maybe you have some payload, some JSON payload that you need to read. And here, this is all given to you by the runtime, by the infrastructure. So this is really cool. And really, you can build some interesting scenarios. But in my case, I'm more of a .NET person. So it's not that I don't know JavaScript. It's just that I feel more confident with C#. So can I actually do that in C#? What would you say?
Yes, definitely. Azure Function supports all most popular languages. That includes .NET, but also Python, Java. It also includes, I think you can run even PowerShell scripts in Function.
Indeed.
Mostly, you can use whatever language you want to use on Azure Function right now.
Yeah, this is really cool. And the fact that you can run PowerShell means that you can also do some infrastructure maintenance, things like starting a VM, stopping a VM, these kind of things. Then, other than that, I would say you can really choose what you feel more comfortable with. So if you are more of a web developer with JavaScript background, then maybe choosing a JavaScript function is good. We also support TypeScript, like we will see in the next session. And for my personal use case, I like .NET Core. I can run that on Windows and Linux. This is quite cool. And here we see that the code is very similar. We have very similar concepts here. And the infrastructure is just abstracted, so I don't have to worry about it. So that's pretty cool. And let's just move on and talk a little bit about typical use cases that we have with Azure Functions. So what would you say, for example, can I build a recurring scenario?
Yeah, for example, if you use a time trigger, you can set your function to run at a given time. And for recurring scenario, for example, if you had some processing, some cleanup of your database you want to do, you can do that using a function. It will be very efficient.
Very cool. And the data ingestion scenarios that we mentioned before, totally supported as well, right?
Yeah, exactly. Functions are also efficient for maybe you've heard of ETL, like extract and transform your data. For that, you can use a function. It will respond, for example, if you have a new file that is added to a storage, you can, if it's a picture, you can just resize it. For example, if you wanted to build thumbnails based on these images. So that's an efficient way just to run your code based on events. So for transforming data, that's a very efficient solution.
Mm-hmm. And loosely coupled custom services. So we talked before about microservices. We say this is often associated with containers, but you can build something kind of like that with functions, right?
Yeah, if you have a very simple, different kind of code, logic code for business scenarios that runs, you can split it in function a bit like microservices, but you can go even further by splitting at the function level. So you can have very different APIs for running all your custom services.
Very cool. No, that sounds like a great scenario. And to be honest, a lot of the activities I do these days on Azure is often based on functions. I do like functions. I like that they don't cost me a lot. That's definitely a good thing. But also I like the separation of concerns and being able to split my things. I'm using quite a lot durable functions these days. So durable functions are a way to orchestrate multiple functions and to take advantage of, for example, running a lot of functions in parallel and waiting for the result. Like let's say I have, I have 1,000 files that I need to inspect. I can run 1,000 functions and then I wait for the result at the end. So it's durable function. It's already a little bit more of an advanced scenario, so we are not going to go into that today, definitely not. Let's move on, but it's good to know that you also have the possibility to have those advanced scenarios. So moving on, would you say that we have a good list here? Do you recommend functions for new projects?
Definitely, especially for use case like I just mentioned in the previous slide. If you have recurring scenario wanting to transform data or build like small services, it's definitely efficient for that.
Great. Supports JavaScript and TypeScript? Definitely yes, we heard that.
Same thing. As long as other languages, you can use JavaScript. That will be our focus for the next session. Mm-hmm. And it also has low maintenance because everything is managed for you by the service. And as we also saw in the previous slides, it scales efficiently. It's made basically to scale for peaks. So that's part of what made it really cost efficient, because like you only pay for when it's running and for what you use exactly. So it's no secret that was our favorite since the beginning, but it's always interesting to see why we wanted to use function for that particular use case.
Absolutely. Now, since we are at this point, I think maybe it's a good point to break here and to check the exercise. So let's take a look at it. So here we have the module, the Learn module. So Microsoft Learn is our learning platform. You have all kinds of exercises. And one thing I did, I already activated the sandbox. So when you go to this page the first time, you're going to be presented with a button. So you need to be logged in with a Microsoft account. It doesn't have to be an Azure account. That's important to know. It's just a Microsoft account. And then we are going to activate that. It just takes a few seconds to do that. So I wanted to do that in advance so that I don't have any issues. And as you can see, it's all public, so you can do that at home, either at the same time as we do here, or later if you want to concentrate on the explanations here. And one thing I'm going to do, I'm going to open the portal, and I'm going to use here this link because it's going to open the Azure portal using the subscription that I am using here in Microsoft Learn. So I'm going to choose here my Outlook.com account. And as you can see, it says down here, Microsoft Learn Sandbox. So it's important because this way you make sure that whatever happens, you're not going to get billed for that. So just make sure that you use the link inside the module here, and then that you see here, Microsoft Learn Sandbox. So what should I do now? I need to create a new resource, right? I need to create a new function application.
Yes, for that you can use the shortcut you see on the start here, or you click on this plus button to create a resource.
Okay, so let's do that. So here we see that we have a number of choices that we can use. And here we see we have function application. That's cool. One important thing to know is that we also have quick starts and tutorials. So if you want to dive deeper into the function and build, for example, your first function using C#, Java, JavaScript, PowerShell, Python, you can do that from here. In our case, I'm going to go straight to the resource creation process. And here, because we are into a subscription where everything is free, we are going to use this subscription. If you want to do that with your own subscription, you can do that as well. Just make sure that it is selected. The resource group, here at this point, I would create a new resource group. It's a grouping of all the resources I'm going to use. But because I'm using the Learn module subscription, I actually already have a resource group created. So again, you can make sure that you select that particular resource group. And now we need to give it a name. So what do we need to pay attention to here?
This name must be unique for the whole Azure, because it will be part of the URL you will be able to use to access your function. So basically, you have to make sure that you use a name that hasn't already been taken.
Exactly. And so here we see my function is not great. My function 1, 2, 3 might work. No, maybe 4. Basically, very often what I do is that I start by prefixing with my initials, and then I use a word. So my initials are LB for Laurent Bugnon, and like this, it kind of makes it more difficult for other people to use that. But again, it has to be unique worldwide. Then we have the publication as code or as Docker container. And like we said, we have the possibility to run some applications as Docker container. But in our case, we want to go as simple as possible. We want to use code, and we want to even do that directly in the web portal. Let's select the runtime stack. And so I know that you like Node.js, right? So let's choose that. But notice that we also have .NET Core and other things. So Node.js, good choice for you?
Yes, perfect.
Okay. 12 LTS, I have no idea what it means. So is that a good choice?
Yeah, it means that basically we're using the long-term support version, which is always best if you want to run like enterprise scenarios.
Okay, very cool. So now we are choosing that. And then the region, we have something like, I forget now, something like 64 regions by now worldwide. You typically want to put an application close to your users to reduce latency. But here in our case, again, we are using a concierge subscription. It's for free. We are going to just put that in Central US, which is the default. Now, one thing interesting is that when you do the hosting, you also have different things that you can do. For example, using a Windows server or a Linux server, you can choose that. You can select here a consumption plan or a premium plan. Can you tell us just a little bit more information about that? What is that?
Yes, basically it affects how you will be billed for running your code. What we really want here is the consumption plan. As you see, it's called serverless. It's really the one that can scale efficiently as with demand. It can scale up and down as there is demand on your different triggers. The alternative is to use a pre-provisioned solution. So it will be a bit like app service, where you pay for pre-provision capacity for running your function. So it won't be as cost efficient for, especially for our scenario. It won't be able to scale automatically, but at least you always pay for the same thing because you have a fixed capacity to execute your function.
Yeah, I think that app service plan is probably a good choice if you already have an app service anyway. Like if you have a website running and you know that this website is not utilizing the web server to its full capacity and you have some remaining capacity to run your function. The premium system could be interesting. It's something where we make sure that the function is always on, because like we said before, we want to optimize the cost of your function. So in the consumption model, at some point after a certain timeout, the function will go to sleep, which means that the next time a trigger comes, it might take maybe a couple of seconds to wake up. That can happen. In the premium scenario, we don't have that so-called cold start. And the cold start is very small. Our engineers always work to make it smaller, but it's good to know that you have a possibility to eliminate it completely, of course, for an up price. Monitoring, etc. I'm not going to configure that right now, but you could also totally monitor it using Azure Monitor, Application Insights, and all those things. I am creating, or rather I am validating what I will submit now. Now I am initializing the deployment and submitting the deployment. It will take just a few seconds. What we are going to do is show you that you can always follow what's going on here in the notification in the Azure portal. And after a short wait, we will see that this function is actually created, and we will see code directly in the web browser, right?
Yes, currently everything is deploying, and we'll see that we will be able to use the online editor just to write and see the code for this function.
That's very cool. Yeah, this is interesting, and so it's a great way to basically try something out when you're learning, right? I wouldn't say that it's really how we develop application in production, because typing into the web browser is a little bit cumbersome and everything, but it can be a good solution if you just want to try quickly things out and understand a little bit better. For example, what does a rec object, the request object contain? What does the context object contain? These kind of things. So very soon it's going to be done. I hope so, at least. Like this, we can switch to the code. What can we say in the meantime? Do we have something else that we can talk about?
Do we have maybe some question on the chat? Don't hesitate if you have any question. Don't hesitate to ask on the chat. We can pick it up and try to answer it.
Yeah, absolutely. Actually, in the meantime, we see that the deployment has succeeded, so we can already move on. So let's do that. So that we move on. So here, this is a new function experience. You might see something slightly different on your website, but it's very, very similar anyway. You see that we have metrics that we can follow here. We have different information about the memory working set, etc., so that we can monitor everything. Let's go to functions here, and then we can already, you see that it's empty right now. We can go and add a new function. And here, this is where we have this choice of a trigger, right? So can you just run us a little bit through those different triggers quickly?
Yeah, sure. So the first one will be an HTTP trigger, basically a web request, if you want to do that. The second one is if you want to use some time-based trigger. And then after that, we have a bunch of triggers based on different Azure services. For example, if you want to receive to base your function on an event, if you receive a new message from a queue, if you receive a new file on a storage or things like that.
Cool, very cool. So for the sake of time, I'm moving on to an HTTP trigger. And so here, by the way, everything is described here. So again, right, if you are not sure what to do, you can do that. One thing that I wanted to check here is what name we want to give to the function. But to be honest, it doesn't totally matter, because now our function application is definitely going to run in an independent manner. So let's call this function say hello. And here I'm going to set the authorization level to anonymous. It's just easier. It means that anybody can call that. If I set function, then the function is going to be called using a code which is unique. So it's a little bit more security. But just for the demo purpose here, I'm going to create this function like that. And since I selected Node.js as an environment, it's going to create this function using JavaScript. And now if I go to code and test, then we will see this function code directly in the web browser. So we have a few things. I'm not a JavaScript expert. I don't totally understand what's going on, but I see here some response. I have hello name, and then I have another thing depending on the name and depending if this name is null, right? And we said before that the name comes from the query string. So I would say a good place here is to try things out. So how do I try this function? How do I test it?
I think you have a button just to run this function right from this web editor.
Okay, or what you can do is actually just get the URL, right? Because it's an HTTP request. So why don't we do that? I'm going to just get the URL. Let's copy that. And now we'll go here inside the web browser. And so if I just put it like that, the name is going to be null, right? I don't have any name. So let's see what happens. And now we see that it actually works properly. It tells me, please pass the name in the query string, right? So let's make that a little bit bigger. So why don't I do that? I'm going to say the query string is whatever you have after the question mark, right?
Yes, exactly. And you can type in name equal and then your name.
All right. In that case, I prefer your name, right? Johan. So it works. Hello, Johan. And really, this is really cool because it's totally seamless. If I say here, hello from MS Learn and save and re-execute that, it should immediately work. So we see that I didn't deploy anything. This just happens. We are almost at the end. I see that we are just a little bit pressed by time. So let's move on to a little bit of a recap that we have. So we have seen that we have an Angular website which exists. We have Cosmos DB. We didn't have the HTTP API, but now we know that we are going to use Azure Functions to do that. In summary, we have shown you a lot of information about different Azure services. What should you choose in that particular case for those particular requirements? We hope that it was useful for you. You have more information in the GitHub repository as well as the Learn module. You can do that quietly at home. And finally, if you like this session and you want to see the other session that we are going to have, the next one is on Friday, September 11. After that, you have Monday, September 14, and finally on the September 18. Thank you so much for joining Johan and myself on this Microsoft Learn session. And thank you so much for your attention and see you next Friday.
See you all. I would add that if you want to ask us questions, especially that's important for the people that will look at the recordings, don't hesitate to ping me or Laurent on Twitter using our handle that will be shared in the chat. Don't hesitate if you have any question, you can just ask us and we'll be happy to answer you.
Absolutely, that's correct. Thank you so much for your attention and see you next time.
See you.